fairly trivial exercise. So in the notes, we've derived the Helmholtz equation for the electric field. Now do the same for the magnetic field, which is just a small variation on that theme, but it just helps to convince you that you understood what was going on for the case of the electric field. Starting point, as usual, are friends, the Maxwell equations in the frequency domain. So the curl of the electric field is minus j omega mu h, and then curl of h is j omega epsilon e. Remember, mu and e are constants. We're working in uniform media. So the idea now is to eliminate e. We know what the curl of e is. So if we take the curl of the second equation, we will have a curl of e on the right-hand side. And then the left-hand side will give us curl of h equal to j omega epsilon curl of e. And again, since epsilon is constant, we can bring that outside of the curl operation. So we have j omega epsilon. From the first equation, we know that this is the value of the curl of E. So that's minus j omega mu h. And that's going to give us omega squared mu epsilon h. As before, we're going to simplify this curl business. So the equation we're going to use is the same as before. Its curl of a vector field is equal to the gradient of the divergence of that vector field minus the Laplacian of that vector field. Let's try and get rid of this term, just like we did in case of the electric field. And for that, we're going to channel the fourth law of Maxwell, which tells us that the divergence of B is equal to 0. B, remember, is mu h, and since mu is constant, we can bring that outside of the differential operator, and we can conclude that also h has 0 divergence. And that's good news, because this means that this particular term can get cancelled. And then finally, if we combine that, we replace curl of curl by minus Laplacian h. And then on the right-hand side, we have k squared h. So again, k squared is omega squared mu epsilon, or Laplacian of h plus k squared h is equal to 0, which is, again, the same equation, but this time with an h instead of an e.